Next unit we are going to finish is dienes, alkynes and aromatic compounds. So today what we are going to finish is dienes. Now what is mean by dienes? Dienes is a hydrocarbon which are having two double bonds. The structure having two double bonds is called as dienes. As you can see in the diagram, this is the first diagram you can see. This is having one double bond at first position and the other double bond at third position. Okay, in this structure also you can see there is two double bond in the structure. There is also two double bond. All the structures you can see here also there is two double bond. Okay, and all the structures you can see there are two double bonds in the structure. So wherever there are two double bonds in the structure, we call that is dienes. Okay, they are basically non-ring compounds. Ring compounds are not termed as dienes, or they are straight. They are the chain compounds having two double bonds. Okay, so this is also called as alkadines. These compounds are also called as alkadines. Now these are classified into three categories, that is cumulative dienes, conjugative dienes and isolated dienes. So let us talk about cumulative dienes. Cumulative dienes are those which are having double bond which are on a single carbon. Okay, let us see this example. This is a carbon having two double bonds. That means double bond, one with this carbon and one with this carbon. So the two double bonds are connected to the same atom. That is called as cumulated dienes. If these dienes are conjugated dienes, if these dienes are having two double bonds separated by a one single bond, that is called as conjugated dienes. That means this is alternate double bond, single bond, then again double bond. Okay, so these two double bonds are separated by one single bond, that is called as conjugated dienes. Then the third one is isolated dienes. This is called as non-conjugated dienes. That means they are separated at least by two single bonds. There could be more single bonds in between. So two or more single bonds are there in between two double bonds, that are called as isolated dienes because they are separated. They have a separated moiety. Okay, so they have a separated identity. So they are called as isolated dienes. So there are three categories of dienes, that is cumulated, conjugated and isolated dienes. Then let us see the preparation of 1,3-butadiene. It's an example of a diene, that is 1,3-butadiene is a molecule having double bond at first position and third position. So this 1 and 3 indicates the position of double bond, and this is butane molecule. Butane molecule having two double bonds at first and second position. That's why it is named as 1,3-butadiene. Okay, so let us see the preparation of this 1,3-butadiene. The first preparation is from diol. Diol is the compound having two OH group in the structure. So this two OH group, that is 1,4-butadiene. This is heated in presence of sulfuric acid, or maybe you can take alumina in the place of sulfuric acid. This is heated at approximately 280 degrees Celsius. So it gives 1,3-butadiene. That means this OH group gets extracted along with one of this hydrogen. Okay, so this hydrogen gets extracted and this OH group extracted. So it forms a water molecule, and at this position also, that at first position, this OH group and this hydrogen gets eliminated to form another water molecule. So there is two double bond is formed in this compound, that is called as 1,3-butadiene. Okay, so next preparation is from 1,4-dichlorobutane. 1,4-dichlorobutane is the compound having two butane structure, one double bond at 1 and 4th. Sorry. This compound is having two chlorine group at first and fourth position. As we have seen in the previous case, there was OH group at one first and fourth position. here we have chlorine group at first and fourth position. So necessarily we are having such compound which are having negative charge because it can be connected with this hydrogen at the second and third position. So it will take this chlorine will take this hydrogen and this chlorine will take this hydrogen along with it. So we are adding alcoholic KOH group, so a dehydrohalogenation process is there. Dehydro, that means extraction of hydrogen as well as extraction of halogen. That is called as dehydrohalogenation reaction. So one of the hydrogen and one of the chlorine from here and one of the hydrogen and one of the chlorine from here gets extracted to form double bond at this first and third position. So this forms again 1,3-butadiene. Okay. Then the third preparation is from N-butane. From N-butane, we are having, this is a butane structure. This is a N-butane. N is, this is a straight chain. ठीक है? जब straight chain होता है तो हम उसको N बोलते हैं. If it is branched, it's called iso, right? So we called it as N-butane because it's a straight chain. So we are adding some silica or chromium oxide at around 600 degrees Celsius, and we are heating this mixture at around 600 degrees Celsius. So it's getting a mixture of 1 butene and 2 butene. Okay, so 1 butene and 2 butene का mixture मिलता है which further gives 1,3-butadiene. We get 1,3-butadiene by this heating. And the next preparation is from acetylene. This preparation is two-step process. In the step one, what we are doing, acetylene is passed through the solution of NH4Cl and copper chloride. Okay, so this is passed, acetylene is passed through the solution and then it gets dimerized. Dimerized means these two molecules gets combined to each other. This carbon attaches with this carbon. So this is called as dimerization. That means if two molecules combines together, that is called as a dimer. So this forms a dimer compound, and when we reduce this compound by palladium catalyst and barium sulfide catalyst, so after this reduction, this triple bond is converted into double bond. So it forms a compound like this. Okay, so this is a compound we get. Then the last preparation is cyclohexene. From cyclohexene, this is a cyclohexene. Cyclo means this is a cyclic compound and hexene means this is having 6 carbon compounds with one double bond. Therefore, it is called as a cyclohexene. Okay. So, when the vapors of cyclohexene are passed from a hot nichrome, nichrome is an alloy. Okay, this nichrome is an alloy which is made up of nickel, chromium and ferrous. So this is an alloy. So we are passing this cyclohexene from this alloy and we are getting this chain opening process. This chain is getting opened. This is broken down from here and this is broken down from here and we are getting 1,3-butadiene. Okay, so these are the preparations of 1,3-butadiene. Then let us see the chemical reactions of 1,3-butadiene. The reactions with chlorine or bromine molecule. When it is treated with chlorine or bromine, first case let us start with the chlorine. It is treated with chlorine in the presence of some inert solvent like CCl4 in this case we are taking. So this is an inert solvent we are taking this. It undergoes the addition reaction. That means chlorine is getting added to this. It could be added in two forms. Either it could add at 1,2 addition or it may add as 1,4 addition. Okay, so two possibility is there. So in this case you can see this is a 1,2 addition and it is giving 3,4. 3,4 why this is 3,4? Because we are starting it from here 1 2 3 because हम जहाँ पे भी डबल बॉन्ड होता है उस डायरेक्शन से हम उसको नेमिंग करना शुरू करते हैं as we have seen it earlier. Okay, So we start naming this compound from this carbon. So this is the first carbon, second carbon, this is the third carbon, and this is the fourth carbon. So from at third and fourth position, this chlorine gets attached. So this is called as 1,2 addition. Then again we can see from here, this is adding at a first and fourth position. So this is called as a 1/4 addition, and this is forming 1,4 dichlorotubutene molecule. Then let us see the addition of bromine molecule. Again, this bromine is added in the presence of some inert solvent, and it see similarly it undergoes 1,2 addition as well as 1,4 addition. So by 1,2 addition, it will go give 3,4 dibromo 1 butene as a product, and after this 1,4 addition, it is getting this first and fourth position, it is getting added, so it is giving 1,4 dibromo 2 butene molecule. So let us see the mechanism of this addition. This bromine is polarized by a p electron cloud of butadiene, and it attacks on first carbon. It attacks on the first carbon to form a carbonium ion. So this bromine is polarized, and this is bromine is attached with this first carbon, and this becomes a carbonium ion because the positive charge is induced in this. So this carbonium ion undergoes a resonance to give carbonium ion 2. This undergoes the resonance, this positive charge gets shifted towards first position and third position. So it shifted towards first carbon and third carbon. So when it shifted towards first carbon, the bromine attacks on this carbon to give 1,2 addition. Okay, so when it is in this position, that is carbonium 1, when it is present in the third position, it will bromine will get attacked at this third position, and we will get 1,2 addition. Okay, and similarly this is a carbocation 2, carbonium 2 ion. That means this positive charge is now at this position, this carbon. Okay, so this at this position the bromines get attached, and we are having one bromine already at this first carbon, so other bromine will attach with the fourth carbon, so it will give 1,4 dibromo 2 butene. Okay, so this is 1,4 type of addition. So since it forms two types of carbocation, carbonium ions due to resonating structures, that's why we get two types of addition, that is 1,2 addition and 1,4 addition, which is forming different products. Okay, so we are getting the mixture of these two products. So let us see the reaction with HBr. Now, when it gets reacted with HBr, on reaction with HBr, this 1,3-butadiene gives 3-bromo 1-butene. So this bromine gets attached to this third carbon. Okay, so this attached with this third carbon, and this double bond remains as it is. Okay, then in the second step, this hydrogen attached to the another hydrogen. Okay, so this hydrogen gets attached over here, and we get this type of product. Okay, so यहाँ पे जो डबल बॉन्ड है ये यहाँ पे शिफ्ट हो गया डबल बॉन्ड, और यहाँ पे जो this CH2 becomes CH3 ड्यू टू द एडिशन ऑफ दिस वन हाइड्रोजन. ये जो हाइड्रोजन है वो इस कार्बन पे, दैट मीन्स फर्स्ट कार्बन पे ऐड हो जाएगा, और ब्रोमीन जो है वो थर्ड कार्बन पे ऐड हो जाएगा. So this becomes 1-bromo 2-butene molecule. So let us see the mechanism of this. So in the first step we have dissociation of HBr. Very first step में हम कभी भी जो भी अटैकिंग रिएजेंट होता है उसको डिसोसिएट करते हैं. दैट मीन्स दिस HBr is broken down with to form H plus and Br minus. This bromine Br minus is there, it's not written over here, it's Br minus. Okay, then a proton attacks on this Cl, that is first carbon. Okay, this hydrogen attached to this first carbon of butadiene to form a carbonium. First carbonium is formed. Okay, this first carbonium is formed. This first carbonium undergoes a resonating structure. Again, to form this resonating structure, that means this positive charge moves to the first carbon and third carbon. Okay, it moves between the first carbon and third carbon, and two carbonium ions are formed. So this bromine attacks to this position, that is third carbon. So it will give 1,2 addition product. If this bromine attacks to this third carbon, it will give 1,3 addition, 1,2 addition, and this 3 bromo 1 butene is formed. If this Okay, so this bromium attacks on carbocation 2 to give 1,4 addition product. Okay, so this carbonium ion is added with this bromine gets attacked to this first carbon to form this 1 bromo 2 butene. Okay, so this is the product. This reaction with then third reaction is with the reaction with hydrogen. When it reacts with hydrogen, it gets attached with this one hydrogen will attach to this first position and one hydrogen will attach to maybe this second position or maybe this fourth position. Okay, so that also give a addition product, that is either 1,2 addition is there or 1,4 addition is there. And the next one is polymerization reaction. So in the polymerization reaction, we get we have already seen the polymerization reaction. Polymerization reaction is that reaction in which addition of the molecules exist. Okay, these molecules gets added to each other in a chain, that may be chain of 2, 3, 4, or maybe infinite chain. So the number of molecule attached, the number of monomers, this molecule, this single molecule is called as a monomer, and it attach n number of times to get a polymer. Okay, so this forms a polybutadiene. Okay, this polybutadiene is formed, which is also called as butana rubber. Okay, so next one is the dial elders reaction. This is a very important name reaction. In this reaction, we have two types of compound which is added, which is called as one is called as dienes. Dienes means we have two double bonds in that, and one is dienophile. This dienophile is a compound in which two carbons are there with which double bond. Okay, so such type of addition, that means this carbon adds at this carbon and this carbon adds at this carbon. So it forms a chain reaction. This form a ring with one double bond. Okay, this forms a so double bond comes at this position, that means जो एक अकेला single bond है ये double bond बन जाता है और बाकी के सारे double bond converts into single bonds. Okay, so all these double bonds convert into single bond and the single bond compound becomes a double bond, so it forms a cyclohexene molecule. So we can take two example of this Diels-Alder reaction. uh, this dialylate reaction is carried with 1,3-butadiene, and it is carried with this malic anhydride. This malic anhydride also has this double bond CC double bond structure. So wherever CC double bond structure is there, it can be added to this to form a 6-membered chain. So this added to this, that is 1,4 addition. This is added to the first position and the another carbon is added to the fourth position. So this is a tetrahydrophthalic anhydride. Okay, so this compound is formed. Then the another compound, that is addition of acrolein molecule is there. So propylene, this acrolein, in this acrolein we can see other this is also CC double bond. So one carbon gets attached to this first one and the other carbon attached with the fourth position of 1,3-butadiene. So that's why the compound which is formed is tetrahydrobenzaldehyde. So this compound is formed by this addition, that is 1,4 addition, and this type of addition is called as Diel-Elders reaction. Now it is important to note that if the Diel-Elder reaction contains dinophile, that is, this is a dinophile, carbon carbon double bond compound, that is called as dinophile. If this dinophile contains an electron withdrawing group, that is C double bond, COOH, COOR, CHO, or any electron withdrawing group, the reaction is facilitated. That means the reaction is going faster. Okay, it facilitates the reaction, and if it is combined with the electron donating group, that then the reaction gets slower. Okay, so that is called as Diel-Elder reaction, and that is